We enter the water in a beautiful crystal blue spring run. The turquoise water just comes out of the earth with this incredible flow, and it spills into the Santa Fe River. The Santa Fe River is this remarkable red color that's stained like tea from cypress trees. And where those two waters mix together, you can look up and see just a rainbow palette of colors. We enter this doorway into complete blackness. We have to pull ourselves against this flow. It's powerful, it's visceral, because you're just feeling this pulsating water from inside the planet. Now we're inside the Floridan Aquifer, and it's the primary source of fresh, clean water for the southeastern United States and over 25 million people. We move through this labyrinth of tunnels. At times, you're squeezing through tiny spaces. And then suddenly you're into this huge, huge room that's floor to ceiling, 30 feet high. These caves are museums of natural history. You experience the geology. You see where the water has carved the rock. You see these incredible layers of mud banks that have been laid down throughout history. And you're looking back in time. It's an amazing natural resource, a seemingly never-ending supply of fresh water. But there are signs that perhaps not all is well down here. In large portions of the aquifer, nitrate concentrations have risen to harmful levels. In some cases, 100 times what they were a century ago. Evidence suggests it's human activity above the aquifer that's causing problems. So the question we've got to ask is, are we poisoning our water? At a park in northern Florida, students with the Cambrian Foundation are learning about the journey of water around our planet.
All right, I want to welcome you guys here today to Craft Gardens. We're going to do an exercise called the Journey of a Water Molecule, where you guys are going to become a water droplet and travel all around our planet as part of the water cycle.
This hands-on exercise teaches that all parts of the water cycle are interconnected.
Water circulates with the currents throughout the ocean instead.
Sunlight warms the ocean water and evaporates into clouds.
How did you get here?
From the glacier.
From the glacier, oh. So you must have melted along the way at some point?
Yep.
The kids move from station to station, collecting colored beads to make into a bracelet. Each bead is an indicator of where they've traveled and how long they've stayed in each part of the water cycle. They soon see that here in Florida, they're spending a lot of time in the Floridan Aquifer.
Groundwater travels many miles through the aquifer.
So you're going to stay in the aquifer and keep on traveling. Let me see your bracelets. Hold them up for me. Let's see what you have. I think everybody should have something very different. Am I right? Zoe, can you give us kind of a summary of where you visited when you were a water droplet?
I went to the ocean, and then back up to the clouds, and then down to the soil, and in a plant, and then back up to the clouds.
Enough of water cycle theory. It's time to get wet.
One thing that's really important is to get kids out in the field and experience things hands-on.
Investigating the waters around the park and the wildlife that lives there is a great way to learn about the health of the local system.
So this little guy is a juvenile dragonfly. They have a gigantic pair of jaws that swings out like a basket, but they are good at catching things like mosquitoes. So a lot of people don't know that our dragonflies spend the first 1 to 3 years of their life in water, and then they spend just a couple of weeks alive flying around as an adult.
This is a water scorpion that's like the water version of a walking stick. And it uses these front two pinchers to collect food.
This is a crayfish that lives here in our rivers, our creeks and streams, and we call it an epigean crayfish because it lives above ground. They live anywhere between maybe 3 to 7 years. They're very good indicators of water quality. That means they're pretty sensitive to pollution. So if you find a lot of different species, that usually means the water is fairly clean. So since this system that we're in now drains a very urban area, I'm really happy with all the diversity of critters that we found.
It's great that the water here seems to be in good health. Up here, it's relatively easy to monitor the water quality, but what about what's below the surface, the groundwater? The millions and millions of gallons deep below the ground, down in the aquifer. How do we check that? Well, that's where I come in. My name is Jill Heinerth, and I'm an author, photographer, filmmaker, and diver. My business card says explorer, and most people would look at that and say, what kind of a career is that? But exploration is what drives me, to witness the unknown. I've spent most of my time underwater swimming through the veins of Mother Earth. Water is my passion, and understanding it so that we can protect it at its source is my quest. The Floridan Aquifer is a giant underground reservoir that spans 100,000 square miles and stretches all the way from South Carolina, through Georgia and Alabama, and throughout Florida. And it lies hidden just beneath our feet, under our schools, houses, restaurants, and shopping malls. Scientists say there's 4 quadrillion gallons of water in the Floridan Aquifer, and it's hard to even imagine how many zeros that is, but it's a lot of water. One of the most bountiful freshwater resources on the planet.
Floridan Aquifer is a giant aquifer. It's the primary source of water for almost every use that we have.
Municipalities tap into it for their drinking water. Agricultural taps into it for their irrigation. Everybody is dependent on that water source to provide them water for their day-to-day activities.
Today, we're in North Florida, and with the help of biologist Tom Morris and citizen scientist Kelly Jessup, we'll be diving Ginny Springs. We'll enter the aquifer and collect water samples and do a survey for animals. We do this to look at the overall health of the system. Max depth around 70, 75 feet.
Yeah.
So I have the smallest tank, so we need to keep that in mind. Cave diving can be incredibly dangerous. Things can go wrong. Your equipment can break down. We have to take enough equipment so that we can always get ourselves home and we can always get a partner home safely. So we always have 2 gas supplies. We always have at least 3 lights so that if something breaks, then you have a way home. You have to solve your problems underwater in place. You can't just swim to the surface. You could get lost. There might be a silt out that clouds your exit and you have to feel your way out on a thin piece of string. For some people, that's overwhelming and terrifying. I think it's important to take risks in life because we're not going to discover anything new unless we're willing to take risks and experience and embrace failure, because that's how we move things forward. That's the essence of discovery and innovation. On today's dive, we hope to collect groundwater samples that can later be checked in the lab for pollutants. And we're also on the lookout for any wildlife. Just like at the surface, signs of life are a great indicator of water quality.
There's an unknown in the cave system that no one sees, and that's basically the water quality and the cave fauna that live there.
To survey the fauna, we need to leave the main line and go to a distant part of the cave where we've previously seen animals. We tie off our own line, and now it's time to explore. This thin strand is our lifeline and our only way back home through this vast underwater maze. Kelly's Hydrolab gear is taking water quality samples every 10 seconds. Our trail leads us through a silty passage. Some aquifer animals prefer these conditions, but for divers, it can be extremely dangerous. One false kick can disturb the bottom, and visibility drops to 0. We slowly make our way, searching. And there they are, blind, cave-adapted crayfish. Florida has one of the most diverse populations of crayfish species anywhere on Earth. Limestone in the aquifer provides the perfect habitat for these prehistoric creatures. And being completely blind, even a bump from a tiny shrimp is cause for alarm. Unlike their distant cousins living in creeks, these crayfish have very long lifespans, maybe longer than 100 years. But all crayfish, above ground and cave adapted, are highly susceptible to changes in water quality, which makes them of interest to us. Seeing many of them indicates two things here: low pollution and high enough oxygen levels to support life. There's more life here too. The crayfish's main predator, catfish.
Catfish are nocturnal by nature. They like to be in the dark. They have those long whiskers, and they have a sensory system down their sides that can feel vibrations. And so being in the dark doesn't bother them in the least. We've been back in caves 4,000 feet back in and 300 feet deep, and there's a catfish swimming along. And you go, what the heck's he doing back here?
The catfish feed on the crayfish, which in turn feed on the poop of the catfish. So way down in this deep aquifer cave, there's a symbiotic relationship going on. A great sign that at least in this pocket of the aquifer, the system could be in good health. But that's not the same story everywhere.
These things live way down there. You'd think they would be just safe as can be. Hardly anybody ever lays eyes on them. But what we do up here affects what goes on down there.
I am very distressed about the health of our aquifer and the health of our springs.
Bob Knight is the founder of the Florida Springs Institute. Over the past 4 decades, he has conducted studies of the ecology of dozens of springs in the state of Florida.
I appreciate it. The biggest water quality impact affecting our springs is the increased levels of nitrogen, that's acutely and chronically toxic to humans. The biggest single source is fertilizer. We use many millions of pounds of fertilizer, nitrogen a year in Florida to have an agricultural economy.
But how do these pollutants get from our gardens, streets, and farmlands into the groundwater of the aquifer? Back at the park, Marissa is about to demonstrate with the help of a cool model, a typical Florida landscape.
We've got agriculture, we have a factory, we have a golf course, a construction site, a residential area, and then roadways, rivers, creeks, streams, and lakes.
Marissa has raided the grocery store for some substitute pollutants.
This is soy sauce. It'll be our oil analog for today.
Okay.
Pour this where you think you'd find oil contaminants in our landscape. And what about on a construction site? Do you think they end up with oil or fuel leaks?
Big machines.
Yeah. Now we're going to be using cocoa powder today to act as dirt. The farm has a lot of soil disturbance before they planted it, and this one happens to be right next to the ocean. What are some other pollutants? What about you, Mary?
Fertilizer.
Fertilizer, excellent. These golf courses use quite a bit of fertilizer. Ooh, that's a lot. No, that's okay. They use a lot of fertilizer. Grass clippings, excellent. Yes, pesticides, please put that in the appropriate locations. Trash is actually one of the bigger pollutants that we have an issue with as well.
And then it rains.
So you can see all those chemicals and pollutants. You see how everything's connected? How the landscapes from the road started to drain to the creeks and streams, and suddenly you ended up with pollutants that may have started miles and miles away in your front yard. But as everything collects over time, you get this really nasty sludge. Some of these pollutants can work their way through the soil and into the aquifer as well. Now, could somebody please pull the plug for me and let's see what happens when that goes down to our aquifer. That's disgusting.
As the rain replenishes the aquifer, it can take many years for some of these contaminants to filter through layers of bedrock and show up in the groundwater.
The water coming out of our springs tends to be about 40 years old. A pollution event 40 years ago, it's going to be showing up today. The stuff we do today is going to be showing up 40 years from now. So it really behooves us to treat the thing gently.
People just assume that when water lands on the ground and goes through the filtration of the earth, that it's going to come out of a spring clean. But clear water is not necessarily clean water.
So how do we keep pollutants out of the aquifer?
The simplest thing a citizen can do is to stop fertilizing. Just stop it.
That's all very well in our backyards, but perhaps easier said than done on a 40-acre farm.
We're here on Gospel Field. It's a 40-acre farm we're raising some cattle on. We're always looking for ways to do things better.
Conscientious farmers Tim and Mike are experimenting with new farming methods to keep pollutants out of the Floridan aquifer. It takes a lot of fertilizer to grow food for their cows, but Tim and Mike have discovered a solution, a cattle feed made from the byproduct of the sunflower industry. They're also diversifying away from just raising beef cattle by growing native crops which require less fertilizer to grow in the sandy soils of Florida.
And we're going to be starting a U-pick orchard with persimmons, grapes, and hopefully finding some other niche crops that fit our climate here. And it'll be a U-pick to where families can come out and be involved with the process, get their hands in the dirt, meet the animals, and pick some of their own food.
The changes Tim and Mike are making here at Gospel Field and the small changes we can make around our own homes are a great step forward.
The pollution and the overuse of the water in the Floridan aquifer is a landscape-level problem. We need much more public awareness of how our individual actions affect the aquifer below our feet.
There is definitely hope, and it all lies in educating everybody about what I call their aquifer footprint.
All of these parts of the water cycle are interconnected. So we have to remember what we do on the surface of the earth is very closely tied to what ends up being in our drinking water, which happens to be the Floridan aquifer.
When we walk into our kitchen and turn on the faucet, we take for granted that clean, healthy water will come out. But unless we start thinking about caring for the aquifer and what we put into it, that might not always be the case. More than just a magical place to explore, the Floridan aquifer is an integral part of the water cycle. It's the place all our water comes from and returns to. And it's up to all of us to protect it.